Menapp U presents The Discriminant. Hey folks, today we're going to discuss the discriminant and what it can tell us about the solutions to a quadratic equation. As way of reminder, here we have a quadratic equation, ax squared plus bx plus c equals 0. And remember that a quadratic is a polynomial of degree 2. And how do we know it's a quadratic in this case? And it's degree 2. We look at the highest term, and that would be the term with the largest exponent. In this case, it's ax squared, and that exponent of 2 tells us that the degree is 2, and therefore we have a quadratic. Right below that, we have the quadratic formula, which will give you the solution or solutions or perhaps no solution to any quadratic formula. And today we are going to discuss this part under the radical, which is known as the discriminant, and we're going to look at what it can tell us about the solutions to a quadratic equation, and maybe save us some work. If we have a teacher who's not using complex numbers and such, then we can already determine before doing the full quadratic equation that we're not going to have any solutions, and that can save us a bit of effort. Also, we might have a teacher who's just testing on the discriminant, so it's good to know what it can tell us. All right, so let's talk about the three types of solutions to a quadratic equation. And when I say solutions, I mean when a quadratic is set equal to 0. Remember that a quadratic is a parabola. It's a U-shaped curve. And when we say it's set equal to 0, we're saying where that curve intersects the x-axis. All right, so in one situation, we could have the curve just hit the x-axis once, like in scenario 1 here. And in that case, the curve is tangent to the x-axis. And remember, our quadratic could be facing up or down. But in this case, we're going to have one real solution. In a second scenario, because it's a curve, because it's symmetrical, we could pass through the x-axis twice. So that would look something like this. And here you can see there are 2 points of intersection, and therefore we're going to have two real solutions in this scenario. And then finally, we could completely bypass the x-axis. We could miss it completely. Curve that looks like this. And in that case, we're either going to say, hey, there are no real solutions here. Or if our teacher is using complex numbers, that's a number that includes a real number and an imaginary component, usually with I in it, we're going to say that we have two complex solutions. So this scenario covers both of those cases. All right, let's get a little bit more specific, though. Let's talk about how the discriminant can actually tell us that's going to happen without having to graph the equations. So in scenario 1, one real solution, how would the discriminant tell us that that's about to happen before we solve for it? Well, in that case, our discriminant, b squared minus 4ac, is simply equal to 0. Now, why would that create one real solution? If you look at the equation above, that's our quadratic formula. Remember, this part up here is our discriminant. We also have a plus and minus symbol right in front of that radical. And in this scenario, if you take the radical of 0, that's simply 0. So that's going to fall out, and you're going to lose that plus or minus. Therefore, you're only going to have one real solution, assuming that b and a are also real numbers. How about the second situation, two real solutions? Well, again, we're going to have our discriminant, and we're going to say that is equal to b squared 4ac. That is when it is greater than 0. When we have positive numbers, that is when we're going to have two real solutions. And based on the previous discussion, that makes sense. If you have a positive under the radical, that can be simplified, that can be solved, and you're going to retain that plus or minus symbol. Again, this is assuming that b and a are also real numbers. How about the third scenario where we have no real or two complex solutions? In that case, our discriminant is simply going to be any numbers that are less than 0, negative numbers. And going back to radicals again, if you try to take the square root of a negative number, we'll say that there's no solution if we're dealing with real numbers. If your teacher's dealing with complex numbers, we can have radicals. Remember, I is the square root of -1. So this scenario where our discriminant is less than 0, that's going to tell us we either have no solution or too complex. And if you're in a class, again, where you're not dealing with complex solutions, there's no point in really doing the rest of the quadratic equation at that point, quadratic formula, because you already know there's going to be no real solutions. We can actually get a little bit more information from the discriminant as well. It can sometimes tell us if we're going to have a rational or irrational answer or answers. So what exactly is a rational number? Well, that is any number that can be expressed as one integer divided by another. So for some examples of some rational numbers, 2, we could write 2 as 2 over 1 or 4 over 2. So any number that we can, at the end of the day, write as one integer divided by a number, 17, anything like that, is going to be a rational number. Radicals, and in a moment it'll be clear why I'm using that as an example, some of them can also be expressed as radical numbers, especially, well, in particular, if they can be simplified to an integer or even a fraction that can be expressed as one integer over another. And that also leads to fractions, of course. Any fraction that's one integer over another, even if it's going to result in a repeating decimal, is going to be a rational number. So most of the numbers that we encounter in school, those are rational numbers. Irrational numbers are those that can't be expressed as one integer divided by another. So the reason I did square root of 9 before is because square root of 3 would not be a rational number. It's not going to be, because you can't simplify that. You can't express that as one integer divided by another. There are some other special numbers like pi and e that we've encountered in the real world, and those also cannot be expressed by integers. All right, so let's put some of this to practice. If you want, go ahead at this point and pause the video. You can try to attempt just solving for the discriminant of this equation and figuring out what it tells you before I do any of the work next, but I'm going to dive right in at this point. So a good idea to write our formula again. We know that our discriminant is b squared minus 4ac. And b is negative 12 in this case, a is 4, and c is 9. So our discriminant is going to be equal to negative 12 squared. Very often your b squared is going to be a positive number. If you square a negative, if you square a positive, those result in positive numbers. If for whatever reason you had an imaginary number for b, then you wouldn't get a negative. But in most cases, if you're dealing with integers or even just real numbers, you're going to have a positive for the first part of the discriminant. And then we're going to subtract our 4, and in this case our a is also a 4, and then our c. All right, so let's clean this up. 12 squared, or negative 12 squared, is 144. 4 times 4 is 16, times 9 is also 144. So our discriminant in this case is going to be 0. So what exactly does that tell us? Well, it tells us that there is one real solution. And because a is an integer and c is an integer and the discriminant is falling out, we know we're going to be ending up with an integer divided by another integer. So we also know that our solution is rational. So we get all that information just from solving for the discriminant before we do the unwieldy quadratic formula. All right, let's try another practice problem. Go ahead here and pause if you'd like and solve, but I'm going to forge ahead. So b squared minus 4ac, that is our discriminant again. Our b would be 17, our a would be 2, and our c would be 21. So in this case, our discriminant is going to be equal to 17 squared minus 4 times our a term, which is 2, times our c term, which is 21. All right, so 17 squared is 289. And 4 times 2 is 8. 8 times 21 is 168. I'm not doing that in my head. I calculated them ahead of time. 289 minus 168 is going to be 121. All right, so what are we learning here? Well, 121 is a positive number. So we are in the scenario where we're going to have two real solutions. Furthermore, 121 is a perfect square. It is 11 times 11. And because a and c were both integers, we're going to end up with an integer on top of our quadratic formula and an integer on the bottom. And therefore, we also know that our solutions are rational. So a complete answer here would be two real rational solutions. All right, let's do one more practice problem. Go ahead at this point, if you'd like, go ahead and pause it. but I'm going to proceed ahead. So b squared minus 4ac, again, is our formula. B is negative 3 this time, A is 3, and C is 1. So our discriminant would be equal to negative 3 squared minus 4 times our A term, which is 3, times 1. And that's going to give us 9 minus 12, and that's going to give us 3. Negative 3, I should say. So what does that tell us? Well, we have a negative number this time, so we're going to have either no solution as our answer, or we're going to say we have two complex solutions. Again, a complex number contains both an imaginary number with I and a real number. And furthermore, 3 cannot be simplified under a radical, or negative 3 cannot be simplified under a radical. A and C were integers. So at the end of the day, we know that these two solutions are also irrational. And we get that all from the discriminant. All right, so bottom line, what did we learn today? Our discriminant formula is b squared minus 4ac. That comes from the quadratic formula. We can use that discriminant to determine the types of solutions we are going to get from the quadratic formula without even doing the full calculation. So in the case where our discriminant is 0, we learned that that is going to be one real solution. In the case where it's a positive answer, we learned that it's going to have two real solutions. And in the case of a negative answer, we're going to have no solution or two complex solutions. Furthermore, in any of those scenarios, we can also determine from the discriminant whether or not our answer is going to be rational and irrational, and that also depends on what B and A are because they appear in the rest of the quadratic formula. So folks, that's all I got today, but before I let you go... All right, Iris, let's tell the folks how they can help grow the channel. Please like, subscribe, comment, especially about what you'd like to see next and how I can improve these videos. Tell your classmates and consider joining the flock on Patreon for extra practice problems, explanation videos, and test-taking tips. See the video description for details.